Hello. Which technology is built into those secondary substations and how can we make them smart and digital? Welcome to Power Grid Expert, the YouTube channel about the distribution grid. Today we are talking about digital secondary substations, how to make them smart, how to make them intelligent, how to digitalize them for the future of our energy distribution grids. A few words about me, Power Grid Expert. I'm offering consulting and services around the distribution grid. That can be protection relays, that can be remote control units, that can be fault detectors, and so on. Here we can see a classic secondary substation with a medium voltage switchgear, and we want to equip that substation. We want to modernize it with modern measurement technology, with modern fault detection technology. And this is exactly what I'm doing. I'm having a look at the old substation and I'm giving a recommendation how to equip them to be prepared for the future of our grids. And as you can see, I'm also doing the installation, the putting into service and testing. If you have all the data from your network, from your grid, you also want to collect that data, you want to visualize the data, and here comes SCADA system, SCADA software, and I'm offering also a service of programming and setting up a SCADA system for small and medium-sized distribution grids. But now back to what we want to talk about, the digital secondary substation. So let's have a look at the overall structure of our energy grid. We have the transport layers, we have the high voltage lines. This is not our focus today. We are looking in the regional distribution area where we have so-called secondary substations. We'll have a closer look immediately at that. The last years we saw a big change here because these green energy generators like wind parks, solar farms, and so on are changing the grid, are changing the load flow, are changing how the network, how the grid behaves during a fault. So we need more technology inside the network to control it and to maintain the stability. So that for sure, that's a classic secondary substation in a concrete housing here. Modern style, of course, there's lots of different styles, metal clad housings, real brick houses, but that's, let's say, the most recent versions. And what's inside? Inside there is the medium voltage switchgear. The medium voltage switchgear has normally an incoming and an outgoing feeder. Here you can see an example how it looks in real life. And we have the feeder towards the transformer. If you think, hey, I don't know what this guy is talking about, then feel free to check out my introduction video to energy distribution grids. The link I will show you also above. Let's continue. We have, after the medium voltage switchgear, we have the transformer that transforms the medium voltage down to low voltage, and we have the low voltage compartment and the low voltage distribution panel with the single feeders normally fused. Basically that's it. This is how secondary substations worked the last decades. There was not much technology inside. The switchgear is non-motorized, no remote connection to any SCADA system. Maybe fault detectors, maybe not. Also no measurement on the low voltage side. And in the old grids, that was enough because we knew the energy comes from the atomic plants, from the coal plants, and is slowly dribbling down to the end customers. So you know what you're putting in the grid on top, and you know what's coming out on the bottom. So you know roughly what's going on inside the grid. With all the wind farms, with all the solar plants, that changed dramatically. So we actually do not know so good what's happening between the generation and the end customer. So we need to put more information. We need to get more information. We need to put more technology, more measurement devices, more control features. And this is what the digital substation is all about. So I made a small animation video about the situation, about what's inside of typical digital transformer station. This is part one. That will give you a rough overview about the components, and in follow-up videos, we will go into details. So far, not much new. We will first have a flight over of the whole system, medium voltage, low voltage, remote terminal unit, and the medium voltage transformer. But now let's have a closer look, and we start with the low voltage compartment. In the low voltage compartment, we have here the supply from the transformer coming, and then this is distributed to the single feeders of the low voltage compartment. That's not visible, so behind those housings there are bus bars. So the single feeders are here, 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 and they consist normally of three fuses. The fuses are a little bit hard to see, but you see these yellowish cubes, and exactly that is fuse number one, fuse number two, fuse number three. So these fuses are protecting those low voltage cables going to the houses, to industrial customers, to which customer ever. We have, of course, the three-phase and the neutral and the earth. And what we have here is a first element of a more digital substation. This is, um, let's say, a built-in multimeter that monitors voltage and currents, plural, coming from the transformer. So we already get an information what's going on here, what is the total supply of all the low voltage feeders that are connected to that transformer. That's already great. In old times, this has been done with these analog meters. Um, and with the digital version, of course, we can connect them to a SCADA system. We can check the maximum and the minimum values and more stuff. And more, we have also single point measurements on all those feeders. That is something new that will come, let's say, in future. And that's another step to a more transparent and monitorable grid. We will have a closer look at that technology in a follow-up video. Now we want to continue, and we are going to the medium voltage switchgear. The medium voltage switchgear is thankfully already putting the rough structure of its of the switchgear on the top, on the front panel. So we have, for example, incoming feeder, we have the outgoing feeder, and we have the transformer feeder. So that transformer feeder here is going to the transformer, and then we have here the low voltage feeders we just saw on the right side. In the medium voltage switchgear, we have, as the name might suggest, we have switches, load breakers, power circuit breakers, depending on the application, earthing, of course, and we have those guys here. And those are measurement devices. They can deliver measurement values from the medium voltage side, like voltages, currents, power, cosinus phi, and so on. And they also deliver, well, let's say their main task is the fault detection, short circuit, earth fault, and so on, and the alarm towards the SCADA system, helping during a fault situation the people who are looking for the fault location to find the fault location quickly. The sensors for voltage and current, the current sensors are normally here around the cable of the medium voltage or around the bushing. We will also have a closer look in a follow-up video here. The voltage sensors are either the voltage information comes out of the capacitive indicators here, or it comes from so-called voltage, from so-called ohmic sensors. We will see them later when we have a look at the transformer. So we're continuing to the RTU compartment, and here we have a box that normally contains the RTU unit, the remote terminal unit. Additionally, a modem which connects the whole system to the SCADA. That can be some wireless technology, that can be 5G, that can be fiber, of course, that can be copper lines, that can be satellite. There's lots of different technologies available depending on what's the best in this situation. And of course, we have the UPS system here. Of course, if we want to control the whole substations in case of a blackout, which is the main or one of the purposes for all that technology here, we need a UPS system that stores enough energy to keep the substation connected to the SCADA and also delivers enough energy to drive the motor switches of the medium voltage switchgear. We continue our travel and we're having a look at the transformer, and here there is the last difference when we talk about the digital secondary transformer station. We can have here, we see here the cable coming from the medium voltage switchgear, and we have here the cables going to the low voltage compartment, and between them of course is the transformer. And what you might see here is this small silver units that are plugged into the connector, into the medium voltage connector, and small cables going here towards the medium voltage switchgear. And that is so-called ohmic voltage sensors. They deliver a precision voltage measurement from the medium voltage side to those measurement devices in the medium voltage switchgear. And these measurement devices, of course, can calculate all the measurement values out of these primary currents and voltages. And also we're using that information for the fault detection. That's it. That's the first part of what's inside a digital secondary substation. In follow-up videos, as I mentioned already, we will have a closer look at the low voltage compartment, we will have a closer look at the medium voltage switchgear, and we will have a closer look at the transformer and the RTU boxes and UPS systems. If you did like this video, I am happy to receive your comments, likes, or follows of my YouTube channel Power Grid Expert. If you have further questions, if you need my help, feel free to contact me. The contact data is below in the video description. Thank you for watching.